Now we're going to take a look at how to chart horizontal flips. Before we do that, I want to look at a few more examples. Let's look at f of x equals a negative x squared. We would anticipate the same as before. This is going to flip horizontally. So here's f of x equals x squared. Now we're going to make our b value equal to negative 1. In other words, we're going to put a negative in front of x. But if you know algebra, you know that if you square negative 1, it remains positive. So negative x squared is exactly the same as x squared. But it makes sense, right? It's not that it didn't flip horizontally. It actually did. But it remained the same graph, and that's because it's already symmetrical over the y-axis. In other words, it's an even function. So if you horizontally flip an even function, it's going to be the same function that you started with. Okay, let's look at tangent of negative x. So go to tangent here, and we're going to make b equal to negative 1, so it's going to become tangent of negative x. And we can see b is negative 1. We can see indeed all of these flipped over the y-axis to become the opposite shaped s. And then finally 1 over negative x. So we're going to start with 1 over x, and then we're going to make b equal to negative 1. So here's our 1 over x graph. We would anticipate our new graph to kind of go like this, to flip over the y-axis. Let's see if that happens. Yes, indeed. The transform graph green is a perfect horizontal flip from our purple graph. Very pretty. Kind of looks like it's a familiar pattern that I've seen before. So in general, how would you chart this? Well, here's our parent function. We're going to just stick with the normal x values for our parent function, negative 2, negative 1, 0, 1, 2. We know our y values will be p of negative 2, p of negative 1, p of 0, p of 1, and p of 2 in general. But we've already proven that if our transform function is determined by making all of the parent x values negative, then we're going to take those parent x values and divide them by negative 1 to give us our transform x values while keeping the same p values or the same y values as our parent function. So those y values will not change. Only the x values will be flipped. The sign will be changed from the parent to the transformed. So therefore, this is what our new general chart is going to look like for f of x when it is a horizontal flip. All the x values will change signs. Of course, 0 stays 0. The y values for the parent will stay the same. Okay, so when f of x is equal to p of b of x and b is equal to negative 1, so in other words, just p of negative x. I'm focusing on b right now because we're going to learn about horizontal stretching and shrinking. Then the parent graph p of x will horizontally flip around the y-axis to reach the transformed graph f of x while keeping the same y value. And one more time, this is what it looks like graphically. You're taking you're keeping the same y values on the left and right? But the x values are becoming opposites of each other. For example, right here we have 3, 1/3. The corresponding point on the transform function is a negative 3, 1/3. That's it for this video. If you have any questions about it, let me know.